Okay, in this video, I'm going to go through page 3, which is about volume of revolution. So we're going to have to be finding the volume of a solid form by rotating a region bounded by the curves and the x-axis. So I'm going to go through this PowerPoint in this video, and this is called the disk method. So if we find the volume of the solid formed by this region, if we rotate it 360 degrees around the x-axis, we are going to get a sphere. Okay, so then we could do this without calculus if we use this volume formula for a sphere, 4/3 pi r cubed. So this equation is just the top half. So the radius of this is going to be, we can see it's going to be 3. So if I just plug in 4/3 pi times 3 cubed, this is going to be 4/3 pi times 27. And then I cancel out. This is going to be equal to 9 times 4 is 36 pi. Okay, so we could do this without calculus, but I want to show you how this method works. If we were to slice this sphere into small slices, we would get cylinders. And the volume of a cylinder is pi r squared h. So we can use calculus to find this volume by taking an integral. Okay, we put pi out in the front, and then r squared is actually going to be this function. So it's going to be f of x squared. And then the height is the dx part. That's the respect to x part. So this formula is in the formula booklet. They actually give it like this. Oh, and we also need from A to B. They give it like this, from A to B, and they put the pi inside, and then they just call this y squared dy. They put it like this, but I prefer it this way. So if we're going to plug this in, from where to where, we're going from -3 to +3, f of x squared. So we're going to take this whole thing and square it, which means we're just going to get 9 minus x squared, because the square root is going to cancel out with respect to x. Okay, and we could plug this in to our GDC and just check. Let me get my GDC. And we can check to see that this is the 36 pi that we got before, in case you don't believe me. Here's my PowerPoint. So 9 minus x squared from -3 to 3. So I do math 9. And yours should open up the boxes where you put in the bounds first, but mine I'd have to do that last. So I'm going to plug in 9 minus x squared. Then I have to tell it the dx part first, and then I go from -3 to 3. Okay, and this tells me 36, and that's because I haven't calculated the pi yet. We want to do the pi at the end. Do not type this into the integral. It will mess it up. So 36 pi, it's the same. Okay, so now if we're going to apply this formula to something else, let me go ahead and write down our formula. So formula for volume is integral. So I'm going to put the pi outside from A to B, and we take our function f of x and we square it with respect to x. So if our function is e to the x, then we don't really even have to sketch this once we know what we're doing. Between 0 and 2, it already tells us. We put the pi in the front, we square e to the x with respect to x. And now, I mean, we could simplify this and we just distribute the 2, so we get e to the 2x. And that's the function we're going to type in to our calculator. So math 9 I'm going to type in e to the 2x with respect to x, and then from 0 to 2. Okay, and this one's going to be a decimal, and then times by pi, and we're going to get 84.2 if we round to 3 sig figs. So 84.2. Okay. So again, why are we squaring this? That's because this formula comes from the formula for a cylinder, pi r squared h, where this is the pi, this is the r squared, and this is the h. Okay, next one. F of x equals root 2x, and the x-axis between 1 and 3. So again, I don't really even have to know what this looks like. I'm going to square this, so I'm just going to get 2x with respect to x, and from 1 to 3. So this is a very easy example. You could type this one in on your own and figure it out. Now this one's a little bit harder because it doesn't tell it, it just says sine x and the x-axis. So I'm going to have pi times, I'm going to have to square this, but I don't know from where to where unless I actually graph this function. Okay, so we can graph. Sometimes you'll have to find the x-intercepts on your own. Make sure we're in degree mode here. Radian mode. Whenever we're doing calculus, we want radian mode for sine and cosine. So I'm going to hit zoom 6. Okay, and sine x in the x-axis. Okay. So let's say from 0, because it should tell us from where to where, because sine goes on forever. So let's just say from 0 to, I'm going to zoom in a little bit or change the window to be just positive. Just a positive window. So let's say from here to here and just rotate that region 360 around the x-axis. We're going to get sort of a spherical shape. I'm going to need to see a little bit below the x-axis to figure out where that x-intercept is. We can just do second calc 0. And this number should look familiar once we get it. It's going to be a decimal, but 3.14159, does that sound familiar? It's pi. So our region is going to be like this, from 0 to pi, but then we're going to rotate it 360 degrees and cut it into slices, remember, just like the cylinder, just like the sphere. So this is going to be 0, and this is going to be pi. Okay, and then we can just type this into our calculator. We want math 9. Now, how do I type in sine squared? I should put parentheses and then sine of x, close parentheses, and then square it. And then with respect to x, from 0 to pi. Again, it's really important to make sure you're in radian mode here. 1.57, that's actually pi over 2. You don't have to know that, but then we're going to multiply this by pi. So we get 4.93. 4.93 approximately. Okay, but we could also be exact here because we had pi times pi over 2. So this would be equal to pi squared over 2 if you want to be exact. Okay, and number 4 is a little bit harder. This one is probably the hardest kind you could get. You've got two functions, so we're going to have a region bound by these two functions, then we're going to rotate it 360. So definitely going to have to look at the graphs of these, and I'll do this one in a different video.